All right, so now we're going to talk about SAS similarity statement. First, let's review. We got all this junk right here. Remember we had the SAS congruence postulate where we had two sides and the angle was between the two sides. All right, two sides and an angle. Well, the A would be between the two S's, all right? If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Similarly, pun intended, we have the SAS similarity theorem. If two sides of one triangle, remember sides, proportional. All right, so if you have proportional sides, you set up the fractions, they all equal each other, so on and so forth. They're proportional to two sides of another triangle and their included angles are congruent, then the triangles are similar. So what does that mean? Let's look at this. Is ABC similar to XYZ? Well, let's just first look at the angles. They have angle 75, 75. Their measures are 75 degrees. All right, so they have congruent angles. Cool. All right, now it's asking me what. Now we're up here. AB is 15. XY is 10. All right, so those are the corresponding sides. 15 over 10, which reduces to 3 over 2. And then it's saying AC over XZ, 21 over 14, which simplifies to 3 over 2. All right, so sides proportional, included angle congruent. So yes, they are similar. And the similarity statement is just that right there. We'll practice writing it again. Triangle ABC, the squiggly line triangle XYZ. That's it. All right. Now I like this problem because it's a little bit goofy. All right, the triangles are oriented in a weird way. All right. They both have an angle 122. So we're using SAS. We got the A part already knocked out. Now, let's think for a second. We got to set up some proportions. 7.5. Which side corresponds to 7.5? It's natural to think 4 because they're both on top, but realize these triangles are rotated. All right, it actually corresponds to 6. So 7.5 over 6, and that's kind of a weird fraction. Let's plug that in the calculator and get a decimal. That's 1.25. And notice how I did big side over little side. So when I do 5 and 4, 5 has to be on the top because that's the big over little, which is again 1.25. So angles are congruent. We got two sides that are proportional. So are they similar? Yes, by side, angle, side. That's it. Nice. All right. Find the value of x in the picture on the right. There's a couple ways to do this problem. This is how I like to do the problem, though. We'll do it my way. All right. So let's just focus on this. Let's say, well, I have this blue triangle. It's a right triangle. The hypotenuse and leg of this big triangle, the hypotenuse is 20, and I have some leg of 17. What about in this triangle right here, this orange one? Well, I have a hypotenuse of 15, and this leg, we don't know. I'm going to call A for now. We don't know it. I'm going to solve for A first, and then that's going to help me find X. So if I can set this proportion, I'm in good shape. I'm going to cross multiply. What's 17 times 15? I don't really know. Oh, it's 255, of course. Divide both sides by 20. A equals 12.75. All right, so I quickly found that, well, this is 12.75. So then what's x? I'm just going to do 17 minus 12.75. And it equals 4.25. Nice. Cool. All right. Now we got 3 problems, and then we're done. All right. Determine if the given or indicated triangles are similar. If so, write a similarity statement. Tap each image to check your answer. All right. So notice really fast that to go from 1 to 3, you're multiplying by 3. To go from 1.3 to 3.9, you're multiplying by 3. All right. So the scale factor is equal. Sides are proportional. And then we have an included angle. This angle is between both of them. So yes, triangle ABC is going to be similar to, let's see, EFD. All right. A. It's a little hard to tell. A corresponds to E. Notice how 3.9 and 1.3, those sides come off of those angles. And then I went to B next, and that was F. And then C and D are the easy one. And this one right here, I'm not even going to do calculations. Notice how this angle, that's an included angle. It's between sides. This over here, that's not included. The 2 given side lengths not included because it's not between, or it's not formed, whatever you want to say. It's not between the sides. So I already know this answer is no. All right. And then this triangle right here, this last problem of the notes, look, we got vertical angles. All right, the vertical angles are congruent. And then look, these sides are actually congruent and congruent. These triangles, ABE and CDE, are actually congruent. Triangle congruent by SAS. And since they're congruent, we know that triangles are similar by SAS. If they're congruent, they're also similar. The scale factor is just 1. So a similarity statement, I'm just going to say triangle AB is similar to triangle CDE. All right, and that's it for these notes. Hopefully you had as much fun as I did.